Thank you.
Sorry, Mrs. Mick always forgets to, and so we have to remind her.
So, there's two ways to do this. And I'm going to show you a way that's different from what you've seen before. I'm going to show you that first. Okay? Now, the other way to do it is just do where you got grams of something and you go to grams of the product. And when you go to the grams of the product, what happens is you'll get two amounts from the two different reactants. And the one that has the lowest amount that it will produce, well, that's your answer, because that's the one that's coming from the limiting. So the one that limits your two answers, or the lesser of the two answers, would come from the one that ran out. And that's how you can figure out which one is limiting. Okay? So, when I do this, we have this thing called, it's called ICE. And what ICE stands for when I do this, I stands for initial. So what I'll do is I'll write this reaction out here so that I have room to work. And then what I do is I'll write the mass of each one above it. So I'll write sulfur 98.2 grams up here. And then for the aluminum above it, I'll write what its weight is, and it's 43.7 grams. Now, what I'll do down here is I'll write I, C, and E. Now, later on, like next semester, this E is going to stand for what's called equilibrium. The C stands for change, and the I stands for the initial amount. So, I stands for initial. Before you get going, it will tell you how much you have of each. The change is how much it loses. So when we look at changes, is how much you have a loss of each one. So in this case, what we're going to do is change is going to be how much you subtract out, or how much actually reacts. Okay? And then E would be the ending amount. So E is kind of like the ending amounts of everything when you're done. So it'll tell you how much. So if you have an ending amount down here that's 0, that's your limiting. So if you come down and you take initial, you subtract the change, you subtract the amount that reacts from the initial, and you end up with 0 on one of these, then that's going to be your limiting. And the other one that ends up with extra left over, that's going to be what didn't react. That's called your leftover amount. Okay? So if you do this right and kind of understand the steps, the first thing you would do is you would divide each of these out by their molar mass. So we would take the 43.2 and divide by, this is kind of a nice one I picked there. You divide by 26.98, and that gives you your initial amount. So when you take and divide by the molar mass, moles are what's left over. So I'm not setting this up as a conversion ratio where you got train tracks. All I'm doing is I'm dividing each of them out by their weight. And then what I'll do is I'll put their mole quantities right here. That's their initial amounts. That's how much we have of each. So we'll go ahead and do that. That's pretty easy to do that. So when I divide this one out, I get 1.62. And then when I divide the next one out, I get 3.06. Okay. Now, what we're going to do is we're going to just guess which one we think is limiting. Okay? That's what we're going to do. We're going to guess which one we think is limiting. Alright? So if we think aluminum's limiting, then what we're going to do is we're going to go ahead and I'm going to step this back. What I'm going to have you do is figure out, divide each one by their number of moles. So what I want you to do is take the 1.62 and divide by 2, and I want you to take the 3.06 moles and divide it by 3. Okay, go ahead and do that. So I'm going to do that underneath. I don't think there's a good way to show what I'm doing here, but underneath.
This has been just doing this for like a while.
Okay, so this, get back out and go back in.
Get back out.
Yeah, just go back out and get back in. So this would be what? 0.81?
Yeah.
And then this one is going to be what? 1.02. Okay? When you do that, the one that's the lowest number of moles is your limiting. Alright? So, I'm not showing that in this step, and you'll just have to remember, how did he get to 0.81? Well, he just took this initial amount of moles and divided by 2. And so he got 0.81. And then did the same for sulfur, and I got 1.02. So the one that is the lower between the two is your limiting. Okay? Alright. So right now we know our limiting. But it asks how many grams of Al2O3 will be produced. Okay? So that's what it's asking you to do. So if this one's limiting, I'm going to subtract both of these. Okay? When I subtract them out, what I'm going to have to do is figure out the change. So we know that this here is going to be subtracting this amount. So it's going to be, we're going to minus 1.62. Okay, and you say, well, why didn't we use the 0.81? But what did we start out with? 1.62. So we're going to say, since this is a lower number of moles once we divide by the coefficient, we're going to go ahead and say that the 1.62 is going to run out. If it runs out and we subtract it out, what's our ending amount? 0 moles. Okay? Now, what do we have to do to go over here is we have to do our mole-to-mole ratio. So we got to take 1.62 and do what with it? For us to go to sulfur and see how much of the 3.06 is actually used up, we're going to have to take the 1.62, but we're going to have to do what with it? Divide by 2,
And then times that.
which is 0.81, times 3. So when we times it by 3, then that would give us our answer here. And so that's what? 2.43. Well, that's subtracted from the 3.06. When you subtract it from that, you get 7.63, right? Is that what you get?
Yep.
That's how many moles you have left over. So, if a question asks you which one's limiting, aluminum's limiting. If it asks you how much is left over in moles, it'd be 0.63 moles of sulfur is left over. Okay? So, we can also we started out with 0 of the Al2S3. Right? We started out with 0. That was our initial amount. We didn't have any aluminum oxide. So if this changed 1.62, subtracted out, and this was a change of 2.43 moles, then how much was gained over here of A2S3? Well, you still do the same thing. You take what? The 1.62 and you divide by 2 and multiply by 1. So you take 1.62 divided by 2 times 1. Did you get done? Okay. Good. Just put it up then. And then, so then you got basically 0.81 is what's here, right? That's how much is added with that. So that's how much is produced, 0.81. Okay, so how much do we end up with here? What's the ending amount? So we're adding here. See, on this side we subtract because we get rid of the reactants. On this side, on the product side, we always add. So it would be 0 plus 0.81, and your ending amount of Al2S3 is 0.81 moles. Does that make sense? Okay, so let me go through this again to see if it makes sense to you. Okay, so what we're doing, number 1, is we're just finding out how many moles we'd have in the initial. So this is how many moles we have in the initial amount of aluminum. This is how many moles we have in the initial amount of sulfur. One of those two is going to run out. Next thing we do is we determine how many, by dividing by its coefficient out in front, we basically are solving, we're finding what x is. Okay, it's kind of like in math, you know, you're finding out what x is. So you take 1.62 divided by 2 and it's 0.81. If you take 3.06 divided by 3, it's 1.02. The one that's the least amount is the one that's limiting. So then that limiting amount, whatever it is, whichever reactant it is, what you're going to do is subtract that same amount from itself so that the ending amount is 0. Okay? Then all it is mole-to-mole problems after that. So you take the 1.62 divided by 2, which is 0.81, times 3, which is 2.43. That's what's being subtracted from the 3.06. And then this is how much you have left over of sulfur. Then on the right side, the ratio is going to stay the same. So the 2 to 3 to 1 ratio is the same as 1.62 to 2.43 to 0.81. That's the same as 2 to 3 to 1. So once you get to 0.81, that's how much is produced. So if we wanted to find out how many grams you would have, what would you have to do with this 0.81 moles? You multiply it by the molar mass, right?
Yep.
And so the molar mass would be 26.98 times 2 plus 32.066 times 3. And it's 150.16. Okay? So then we take that times 0.81, and it tells us the amount. It's 122 grams we make. Now, you might prefer the other method, and I'll show you the other method here in a second. Okay? But I think once you do a few of these, I think we did it last year. Once you do a few of these, it's pretty easy to do. And you know what's nice about this? If you're asked for how much is in excess, all you have to do is multiply that by 32. All you have to do is take the 0.63 and multiply by 32.066. Now you have excess. And you don't have to do a whole separate problem. All your data is there. You just have to be able to use it. Okay? So maybe I'll have you try